Today I have 3 new pieces of Apollo hardware, thanks to my friend Jimmie Loocke. I have 2 Amplifier 1% 800 cycles per second modules, and 1 AAC filter and multivibrator 800 cycles per second module. These are all PSA modules from the power and servo assembly for Block I. They're kind of a mix of ages. The one on the left here, this amplifier, is quite old. It's more or less the original design that they made with Series 0. It's marked not for flight use in the bottom right there. So just about as old as you can get for these PSA modules. The one in the middle, this amplifier is of a configuration that would have flown, for example, on AS202. It's kind of a midly revision. It was revised more before Apollo 4 and 6. And then the one on the right is quite late. The AAC module is a later design that flew, for example, on Apollo 4 or Apollo 6. So what these modules do is, as a pair, the AAC filter and multivibrator module and the amplifier 1% module generate the 28 volt 800 cycles per second reference used by the resolvers in the inertial measurement unit and also the optics. So when you're trying to power up a coupling data unit, for example, it's a very useful thing to be able to generate, is the reference for those resolvers. The way it works is that the AAC filter and multivibrator module has a multivibrator down here that takes in synchronization pulses from the Apollo guidance computer. There's 2 800 cycles per second sync pulses that come out that are 180 degrees apart that run this multivibrator and lock it exactly onto 800 hertz. If it's not locked, it runs like around 750, maybe a little bit slower. This generates a square wave, which goes through a filter with a massive inductor to generate a sine wave, whose amplitude starts at around 2.2 volts RMS. The output of this filter goes into the amplifier, the 1% amplifier. This amplifier has a gain of around 21 to 22 volts per volt, so it boosts the signal way up, generates a 28 volt, well, nominally a 28 volt, but potentially much smaller or much larger sine wave on the output. As you can imagine, with a default 2.2 volt RMS signal coming out of the AAC filter and multivibrator, going into something that's nominally 21.6 volts per volt, you're going to get up to like around 40, 50 volts at the beginning when you first start this up. The output of this amplifier has a feedback path that goes back into the AAC filter and multivibrator module to the AAC portion of it, which is this bit up here. That is automatic amplitude control. There is a level sensor here that essentially detects the positive peaks of the 800 cycles per second sine wave and uses those peaks to charge up this capacitor. And the DC level of this capacitor is able to steer the amplitude of the output of the AAC filter and multivibrator module. So it starts at 0 when we first power everything on, but then as that capacitor charges, it pushes down the output. And then, of course, because there's a discharge path for that capacitor, it has a tendency to discharge if the peak detector isn't firing, which will cause the output to naturally rise. And so these tendencies balance out, and it controls exactly to 28 volts RMS. So I have everything wired up here. The Apollo guidance computer is being replaced by this board on the right here. This board has an FPGA on it that's running the FPGA AGC, and then, as you can tell, there's a whole boatload of pulse transformers that are implementing all the I/O circuits of the AGC. And the rest of it is pretty much just wiring between the AAC filter and multivibrator modules and out to the power supplies and to the AGC. So I'm going to go ahead and turn this on. I'm going to start with the power to the AGC interface circuits. When I do that, you'll see the yellow and pink traces on the scope, which are the set and reset sync pulses at 800 cycles per second. You'll see those come on first. So there's our sync pulses. Next, I'm going to turn on power to the PSA modules. And as I said, it's going to be way higher than 28 volts RMS to start. And it's also going to be quite distorted. So, coming on. So the blue is the output of the AAC module, green is the output of the amplifier, and the AAC is starting to kick in now. It's bringing it down, and we have stopped around 28.59 volts RMS. That is actually in violation of the spec. It tends to drop as the AAC module heats up, I found. It'll stop around 28.46 volts RMS. I think that might just be because I'm not loading this anywhere near as much as they originally did. The spec calls for this to be tested with a 56 ohm resistor, which is like 14 watts at 28 volts RMS. And I have maybe a tenth of that. So if I use this with the CDU, I'll probably have to adjust the feedback loop a little bit to trick it into pushing that voltage down just a little bit more. But kind of unsurprisingly, I guess, at this point, all of these old PSA modules seem to work absolutely great. They're doing exactly what they're designed to do. Didn't really have any problems with them. So I'll turn it on and off a couple more times. So we start off with a very large, very distorted sine wave. That was drawing about 400 milliamps, and then it's coming back down, and now we've stopped at 194 milliamps power for this module. And a nice clean sine wave on the output. So I've powered up this other module too, this amplifier, and I can talk about it and just wire it up as I do. It does also work, but it doesn't work quite as well, I would say. I think the sine wave on the output might be very slightly more distorted. But also it draws like twice as much power as the later amplifier. And I'm actually not entirely sure why that is. They have a completely identical design. Like, they use all the same components, as far as I can tell. They didn't change out any of the parts or change any of the values. But it's a lot more power hungry and slightly more distorted. So there might be something slightly wrong inside. So I'll go ahead and turn it on. Does the same thing with a big distorted wave at first, but then it brings it down. This one also stopped at 28.56 volts. That's really in control of the AAC module and not the amplifier. But this one is drawing 433 milliamps idle instead of the 190 milliamps idle. And there's a little bit more of a a dent in the top of the sine wave, which is probably fine. But I think these two factors are probably why this module is marked not for flight use, but it's fine on the ground as long as you heatsink it, I guess. But yeah, 3 working Block I PSA modules. So thanks a lot again to my friend Jimmie Loocke, and hopefully we'll have more Apollo hardware to show in the future.